Children, welcome to channel Sube. Today I am going to discuss question number 30 of 2019 Physics New Syllabus MCQ paper. An ideal gas expands from state A to state C along two different paths, ABC and ADC. ABC is this one, ABC, and ADC, like this. These are the paths. So the beginning, the start point is this one for both paths. The end point is this one for both paths, shown in the PV diagram. The heat absorbed by the gas during the process AB and BC are 200 joule and 700 joule respectively. The heat absorbed, that means delta Q. Delta Q equals, for this part, for AB given 200, then delta Q for BC given 700 respectively. What is the change in internal energy? Internal energy means delta U. When the gas expands along the path ADC, ADC is this path, so they ask the delta U, internal energy of this path along this path, expands along the path ADC. So what they ask is this one. So children, I have to explain the lesson a little bit, because most of the children say that this thermodynamics is very difficult. Therefore, just without just explaining the question, I will remind you, and also if there are theories, if there are something that you haven't learned clearly, and if there are doubts, you can get all those clear if I explain a little bit, because then this video will be more helpful. So children, what they ask is delta U, that is internal energy, change in internal energy. So the heat, what is this delta Q? They have supplied heat to this sample of gas, and here also delta Q, that means they have given heat by using firewood or petrol or whatever. They have somehow given some heat, that is we denote by delta Q, so it is 200 joule and 700 joule in these AB and BC parts respectively. So first of all, we have to clear what is this, we have to get clear what is this internal energy. So I will explain it a little bit. First of all, I will explain these quantities first of all a little bit, then let's go to the question. So what I have to explain is now delta U. Delta U. Let's take this first portion, first part, this part of this incident, A to B part, A to B. What they have done to the gas sample. Here you can see, obviously the pressure has increased. Pressure has been increased, like this. Pressure has been increased from 2 to 6 times 10 power 4 common. Volume here constant, 3 times 10 power minus 3 from this point to this point. So there are two parts in this total path, total incident. So let us take this first part A to B. What has happened? Pressure increased, volume constant. So let's draw a container. We must have a container to trap gas without leaking, because the mass must be constant in these questions. They don't say that, but we know that in the lesson we have learned that. So this one is the piston. This one is the piston. So the container is like this. Imagine. So there are gas atoms like this. So what has happened? A to B. So this one is when it is at A. So volume equals 3.3. Just I take 3. I mean, only when we substitute to the equation, we take this 10 power minus 3, but here for convenience I just take 3. So volume equals, no, I draw this point, this point A, here I have denoted it. What is the pressure? This one. Pressure is this one, 2. Just we say pressure equals 2. So volume this amount, pressure this amount. So what has happened? The state has been changed to B. Let's take some time because we have to explain it a little bit. So at B, what has happened? The pressure is 6. Pressure is 6. P equals 6. Then what happened to V? V same. 3. So imagine, without changing the volume, how can this happen? Pressure increased to 6 from 2. How can pressure increase like that? There are 3 things we can change: pressure, volume, temperature, and also mass. Mass, however, constant here. We don't have to take that in, because usually mass is constant. So these 3 are the quantities that we change and find the relationship. So we have found it in the relationship. So those are the equations that we called. What is the quantity that we have not written here? We have written P equals to V, written 3. What about T? About T, it is not mentioned in the question even, and also in the lesson. Most of the times I haven't seen when this lesson is taught, they don't talk about the temperature. Because in this graph also P is there, V is there. They explained P and V only. Even children don't ask about what happened to T. So there is the problem here. That is why you can't understand this lesson. Therefore, let us consider now the temperature. So how can we increase pressure without changing the volume? So now imagine the pressure cooker. So the pressure cooker is like this. So what we have to do, we lock the lid like this, and at the beginning this hole also closed, because there is a weight. By that weight the hole is closed. So we lock this end, so there are air or whatever we cooking, but however surely there is air, normal air. So the pressure at the beginning we know low. When we heated up it, what happens? When we heated up it, the pressure increases, no? We know that, because by opening this valve, the pressure, the gas release, the vapor goes out. So that is because of increasing of pressure. So that we can understand. So to increase the pressure like that, under volume is constant condition, to increase the pressure, what we have to do, we have to heat it up. So that is what they have done. It is not explained in the question, but we can guess, because they have given heat here. Delta Q is heat. If you know that much, you can guess it. So somehow you should have common what we called common sense. You should have common sense to identify that the T must have been increased here from T1 to T2 by heat in this, like this. Heat has been given. By heating up, we can increase the pressure up to from 2 to 6. So that is not explained, but you should have common sense to identify that the temperature must have been increased. So the temperature here is low, then temperature here is high. That is what you have to identify by your common sense. So if the temperature is increased like that, what are the changes that happen to these air particles? Surely the pressure increases. How that happen? How does it happen? If we increase the temperature, increase in temperature means we give heat, delta Q, we give heat. So these atoms absorb this heat, and kinetic energy of those atoms increase. So kinetic energy increase. We call this kinetic energy internal energy, delta U. Internal energy. So due to this temperature change, T1 to T2, temperature change equals T2 minus T1. Due to this temperature change, the internal energy, that is kinetic energy, say U1 here, U2 here, the kinetic energy has been increased delta U by delta U. Delta U means U2 minus U1. That is the kinetic energy. To increase the kinetic energy, the origin is, the source is the increasing of this. That is the reason. The temperature change has been caused to increase internal energy. So there is a internal energy change now, delta U. So if there is a delta T, then only there is a delta Q. You must know that, otherwise you can't solve these types of questions. So we can write it like this. If there is a temperature rise, then there will be an internal energy rise. Without temperature rise, there will not be any internal energy rise. So that is the theory you should understand to solve these types of problems. So children, I explained here how you can come to the conclusion that in this part the temperature must have been increased by using your common sense or using your intelligence. So I will show you there is another way to come to the conclusion that at this place the temperature is lower, at this place the temperature is higher, and there must have been a temperature rise. So you must have learned Boyle's law. When you learn Boyle's law, we plot a graph like this, taking volume to this side, taking pressure to this axis. So you plot the graph like this, you might do an experiment sometimes and take the readings, take the real readings and plot the graph in the laboratory. Actually you can do that too. Sometimes you might just learn from your teacher that the graph is like this, and you write P proportional to inverse proportional to volume inversely like this. And also you learn PV equals constant K and P1 V1 equals P2 V2 like that. You finish that lesson, Boyle's law, and sometimes you might solve a mathematical problem, and that is all you learn. That is the problem. That is the problem where that is the lack of knowledge that arises here for you to understand this problem. If you if you really learn this Boyle's law, you must write here the temperature at this point, at this whole incident. The temperature is constant, they say. It is included in the Boyle's law at constant temperature, they say that. So T, you must write this temperature. You must consider the temperature in this graph and you must write it, otherwise you will face problems here when you try to solve these types of questions. So if you write like this, the temperature is 300 Kelvin. Suppose we did this experiment at 300 Kelvin temperature, and we received a graph like this. So another day, say the temperature is 310 Kelvin. Then we did the suppose we did the experiment again, and we plot the graph in the same paper, in the same graph paper. So we can see the graph is like this. When the temperature increases, the graph will be like this. It displays to this way, like that. The graph goes like this, away from the origin at higher temperatures. Say this one 400 Kelvin, say this one 500 Kelvin. So like that, when the temperature increases, temperature is constant, that is sure, that is okay. The temperature is constant along these points, here also 300, here also 300. So like that, temperature is constant along all the points of the same graph, but the temperature increased, all the points will be increased to these places. Volume has been increased and also pressure has been increased, like that. The graph is displaced to away from this origin. So that is the knowledge you should have about this temperature. So that way you can identify, if you plot Boyle curves in this diagram which is given, that way also you can identify that this temperature is low, this temperature is higher. How? You have to plot Boyle's curves here like this. This one, this one, this one, this one, like this. So surely then you can identify this point belongs to this curve which is at a lower temperature. This point belongs to this curve which is at a higher temperature. So like that you can identify, if you know Boyle's law like this, how I explained, then you can identify that this point is at a lower temperature, this point is at a high temperature. So that is how I came to the conclusion that this temperature is higher, this temperature is lower. So you should study this graph like that. So then let's go to the other thing. So finally we come to the conclusion that temperature at this point is higher. So internal resistance, internal energy also therefore higher. U is higher than this place. So therefore there is a delta U value here. Sign is positive because this one is higher, this one is at lower internal energy. So that is what I explained here at the beginning. If there is a temperature rise, there will be an internal energy rise. If there is an internal energy rise, there is a difference, that is the delta U. So there is a delta U as well, because the temperature is higher at this point. So now we discussed about temperature and internal energy. So what they ask is this internal energy. This internal energy they want, but here also there is an internal energy. And then here from B to C, what about the temperature? Now you should be able to decide what about the temperature. Just you have to draw Boyle curves, a Boyle curve across this point and another Boyle curve across this point. So what has happened? It has displaced like this. So the temperature must be here, higher than temperature here, it is lower. So like that the temperature is higher at point C than point B. So if there is a temperature increase, there must be a internal energy increase. There must be an increase of internal energy. So there must be therefore internal energy change, positive internal energy change in internal energy there must be. So that now you can identify like that, because I explained the first one. So let's now talk about delta W, because there are three symbols we use: delta W, delta U, delta Q. Now we have covered these two already. We have to then go to delta W. So let us talk about delta W. What is delta W? The work done. Work done. How does a sample of gas, how does it do work? How does it do work? So imagine a situation like this. There is a cylinder, piston, and arm, rod of the piston. So imagine that there is a lever here, lever like this. There is a lever. So this lever can rotate around this point like this, it can rotate, and this point also free to be rotated. So there is a weight hung here, weight hung, say W. So there are gas particles, the sample of gas what we talk about. So at initially it is at this level, the weight, we have to measure the weight is at this level. So there is a volume, there is a certain pressure, there is certain temperature. If we supplied heat, say delta Q, so that means we gave some heat to this gas, whose value is delta Q. We gave some heat, suppose 500 joule, by heating like this. When it is being heated, what are the changes you can see, you expect to happen? What are the changes? This gas must be expanded, then this piston must move up like this to this, say this position, then this lever also lifts like this. Then what happens to this horizontal bar, that also rotate around this point like this, that rotates because here is the pivot and the object is lifted like this to a higher level, to this level, say H. So this weight is lifted by this system, by this machine, we say. So by this heat that we gave, this weight has been lifted. So that is the work done. If something is lifted, some work is done. So this is the work. If we want to lift something, we can use this machine. We can trap some air in a cylinder like this and arrange the parts like this and heat it up. So then we can lift this weight. So some work is done. Some work is done by the machine. So that is what we call delta W. So surely this gas, the temperature of this gas must have been increased. The temperature must have been increased. If there is a temperature increase, there must be an internal energy increase. So therefore delta U must be positive. Positive means we have done that. We have done that. It is increased. If the internal energy is increased, that is, we write as positive. If we gave heat to the system, we write delta Q positive. We gave it, but we write it as positive because we write the sign positive or negative as the way we do it, normally. So we received this work, so that also positive. We received this, there is a benefit of this machine. We received work. So imagine that delta Q is 500. The energy of this internal gas increased from 300 joule. Then what happened to the other 200? 500 given, so there are 300 already as kinetic energy of this gas. What happened to the other 200? That is appearing as here, work done. That must be other 200, the remainder 200 joule. So we can write an equation. We gave 500. So using that, there is 300 already as internal energy. There is 200 already as work. 200 as work. So equal. This one we gave to the system. This amount we received. This amount we received. That is the this one is the output. This one is the input. So like that we can write the equation. So this one is delta Q. This 300 is delta U. This one. This 200 is delta W. So now we have an equation. Delta Q equals delta U plus delta W. This is not something else other than conservation of energy. Conservation of energy. input output. Input output. This is the normal equation that we know as conservation of energy. I don't know why they call this first equation of thermodynamics. So they say like this to this equation, first equation of thermodynamics, but it is not other than something else other than conservation of energy. So somehow they say this phrase, they say this phrase, so somehow it is the conservation of energy. So you can use this equation now. Now you have identified, you have cleared all the doubts about delta U, delta W and delta Q. So let's now write the equation to this path from A to C. Without dividing into two parts, we can write it, we can take it as one. So from A to C, delta Q equals delta U plus delta W. This is the first equation of thermodynamics. So what is the delta Q given? What is the energy given to this path, to this total path? Here 100, here 200, altogether 900, because we are writing the equation from A to C. We consider the both parts together, then 7, 8, 900. Then internal energy, we take this one and this one together as delta U, together. We don't have to divide it into two parts, together. Say total internal total increase of total change in internal energy is, total change is delta U plus delta W, work done. So we didn't talk about delta W here. Here delta in this question, the delta W in this question, even though we discussed here what is delta W, that is work done. So to have a work done, this piston must go up, otherwise this weight will not go up. Therefore, to have a work done, what is essential, this piston must go up. To go up the piston, what is essential, this gas must be expanded. So the volume from this level to volume to this level, it must increase. The volume must increase, otherwise this object will not get lifted. So therefore the volume at this place, say V1, at this place we say V2, so there must be a volume change. To get a work. That is very important. So you must keep in your mind, to get work done, there must be a what? Volume increase. There must be an increase of volume. So that is the theory you should know to solve these types of questions. So that is why I explained. There must be a volume increase. There must be a change in volume like this. then only we get a work done like this, because the piston must go up, otherwise we don't get any work done, because this object must be lifted to say that we got a work done. So therefore in this graph you have to check whether volume has been increased. In this part volume has been increased, because 3 to 6 volume has been increased, but in this part volume is constant, so only in this part there is a work done. Here delta W is 0, no work done in this first part, because volume has not changed, volume is constant. We know if volume is constant, this piston will not go up, then this object will not be lifted, so no work is done then. Therefore the volume must be increased to get a work done. So in this graph only in this part we can see that there is a volume increasement, but here in this part there is no volume increased. So however there is a work done, however there is a delta W at least in this part 2. So that is what we now consider. So there is another equation to find out this delta W. Delta W equals P delta V, because we can derive it from this diagram itself. The pressure is P, the pressure is P, so the change of volume is delta V. So we can show that the pressure times delta V equals work done here. This work done here equals to pressure times delta V. So therefore I am not going to derive it here, because we have to consider the force, we have to consider the cross sectional area. It is a little bit longer, therefore I don't derive it here. So you have to remember this, keep in your mind this equation delta W equals P delta V. So here we can substitute it in 900 equals delta U plus P delta V, P delta V. So 900 delta U plus, what is P? What is P? So we are going to calculate this delta W, therefore we have to get the value of P for these 2 points. What is it? This one, 6 times 10 power 4, 6 times 10 power 4, because we are going to calculate this delta W for these points, because at this region there is no delta W, we discussed this earlier. So 6 times 10 power 4, P is that 6 times 10 power 4. What is delta V now? Delta V is this change, because from here to here 6 minus 3, 10 power minus 3, there is no much room, therefore I take it down like this. How much? 6 minus 3, you have to write it like this, otherwise just don't simplify this and directly don't write here 3, because already there is another 3, this one, therefore you have to write it like this. 6 minus 3 times 10 power minus 3, then you can write 900 equals delta U plus 6 times 10 4 3 times 10 minus 3. So cancel 3, then this one is 60, 60 times 3 is 180, delta U 900. So delta U equals 720 joule. So we found what we found. We found the delta U, internal change in internal energy, for this side, for this path we found the total one, At the beginning itself I said this one and this one I take as delta U as a single value without considering separately. So we found the internal change in internal energy for this path, but what they ask is this one for this path. What do you think? What do you think? Don't you identify that this one equals to this one? Why? Internal energy is increased by the temperature if the temperature is increased. So if the temperature is increased, the internal energy is increased. So temperature increased from this point to this point. That is common for this path and this path. The initial temperature for this path, is this one. Final temperature for this path is this one. In the same way, the initial temperature is this one for this path and final temperature is this one for this path. So therefore, the temperatures are common. Then the delta U values must be same. Therefore, whatever the path we followed, it doesn't influence. The values are same. Therefore, we found the delta V as 720 for this path, but it is equal to what they want us to find here, this one. So therefore, the answer is this one, 720. I think you understand. If you understood, please subscribe my channel. Thank you very much for watching my videos. Please do it again and again. Then see you tomorrow. Goodbye.